Great mathematicians, I'm here to help prepare you for your test on Friday. The test this week is going to be on additive and multiplicative patterns. It's also going to cover exponents that we've been doing this week, prime factorization, and a little bit about variables. So we're kind of covering everything we did the week before Christmas and the stuff that we did this week. I want to talk first about prime numbers. That's what we've been working about this week, and I want you to write all these prime numbers down. 2, 3, 5, 7, 11, 13, 17, 19. Go ahead and pause it right here. I've got you a good shot so you can get it, and we'll get them all written down. Okay, the reason I want you to write the prime numbers down is this is one thing we're still a little iffy on. Some of you are understanding prime numbers, some of you are still not getting them. Prime numbers are the numbers that the only way you can get to them is 1 times itself. You can't take 2 times something or 3 times something. You can only do 1 times itself to get it. It only has 2 factors. So we're going to look at a factor tree. Here's 34. You're going to have to be doing some prime factorizations. And if I was going to factor out 34, I would say, first, well, it's an even number. Since it's an even number, I can divide it by 2. So I put down my number 2 right over here. And then when I divided 34 by 2, I got 17. Then I'm going to look over here at my prime number chart. And since I see 17 is on my prime number chart, I know I'm done. I don't have to do anything else to this. Some of you guys are including, saying 2 times 1 times 17. You can't do that. You don't have any 1s as a prime factor. 1 is not a prime number. Prime numbers start with the number 2. 1 isn't prime or composite. So make sure that you're stopping at your prime numbers and you're not stopping before them. Some of you guys are stopping at 10. 10's a composite number. It can still be broken down. You've got to keep going until you can't break them down anymore. So you have some prime factorization questions. You're also going to have a question that's going to look something like this. What is the prime factorization of this number? So this number I picked was 36. And what you have to do is you have to find the prime factorization of 36. 2 ways you can do this. You can make a prime factor tree. And I know that 36 can be divided by 2 since it's even. So I'd say, well, 2 times 18. And then I can break up 18 because it's composite. It's also even. I can go that way to figure it out. Once I have all my prime numbers, I can come over here and I can find the one that goes with my prime factorization tree that I made. The other way that I can solve this kind of problem is I can look at these numbers and I can try doing the math and see if it works. For instance, here I have 2 times 3. 2 times 3 is 6. And then I would take that 6 times 5. 6 times 5 is 30. 30 is not 36, so this can't be the right answer. I can go to my next one down here, and this is 2 times 2. Well, that's 4. 3 times 3 is 9. 4 times 9 does equal 36. So I know that this right here is going to be my prime factorization. So you have 2 options. You can do the factor tree, or you can just go through here and you can work the math and make sure that you get the math that goes with the number. The other questions that you're going to have on your test are going to be to do with additive and multiplicative patterns. We talked a lot about this the week before Christmas. We talked about additive pattern like x plus a. And here you have your additive pattern, and you can tell it's additive because the numbers are increasing by 1 on this side and they're increasing by 1 on this side. But over here is a multiplicative pattern, y equals ax. This side, we are increasing by 1, and this side, we're increasing by 3. Since we're increasing at different rates, we know that this is multiplicative and it's not additive. So I can look at these patterns, I can figure out what they are. On your test, you're going to have a question that's going to show some patterns like this, and it's going to ask you what is basically the missing variable. So I'm looking for a. I just decide, well, how do I get from 3 to 6? How do I get from 3 to 9? And I know 3 to 6 is 3 plus 3. 3 to 9 is 3 times 3. So the number that would work for both of these would be 3. That would be my answer. You're going to have a question very much like that. You're also going to have some questions about tables. It's going to show tables, and you're going to have to decide what kind of pattern is it. Is it additive? Is it multiplicative? You might have to decide. It may tell you it's an additive pattern, but you got to figure out what number goes in there. Or it's a multiplicative pattern, but you have to figure out what you're multiplying by. Or it may just show you a table, something like this one over here, but this number is blank. And you have to decide, well, I'm multiplying times 3, and 4 times 3 is 12, so the number I'm missing is 12. You're going to have some problems like that also. So I would take some time right now to look back over your interactive notebook. We went through order of operations in class yesterday. Make sure that you kind of go back and review that so you're feeling good about that. Review on your paper. You should have written down your prime numbers. When you're done with all this, turn it in to me, and you'll be ready to take your test.